Autodesk. I'm going to start now. So welcome to the ASEE Autodesk contest webinar. Hopefully in this short time we're going to spend together, you'll be able to answer any questions people might have. I'm going to start with introductions here. So my name is Fabiola Clayton. I'm an engineering program manager here with Autodesk Education Experiences. My background is I have a bachelor in architecture and urban design, and I always wanted to be involved in education one way or the other. So I did a specialization in pedagogy for higher education and a master's degree also in architecture, where I was able to do an interdisciplinary study to figure out how the space affects students in the learning space. I always wanted to continue this journey in education. So right now I'm a student again, doing a PhD in engineering education at Purdue. And on the ASEE side of things, I volunteer by being a board of two divisions of ASEE, the corporate membership division and the design, education, design and engineering division. Next, I am going to introduce you to Josh. Josh, welcome to our webinar and thank you for being here today.
You're welcome. Thanks, Fab, for inviting me. My name is Josh Nelson. I am the program chair for mechanical engineering technology at Ivy Tech in Lafayette. I have been with a college for a little over 8 years now. I was an Autodesk University conference speaker in 2020, and I've been a few times, really enjoyed that. I've learned a lot of CAD along the way. I have a bachelor's degree in English from Purdue and a master's in mechanical engineering technology also from Purdue. So a lot of switch there, but I've learned a lot. And I, like Fab, I kind of am a lifelong learner and educator. So thanks for having me.
Thank you so much, Josh. And today we have a special guest joining us from ASEE, Geraldine. Thank you so much for being here.
Yes, good afternoon, everyone. Thank you, Fab, for having me, and thank you for all our attendees that are here today. So I'm a senior manager of pre-K-12 activities and diversity, equity, and inclusion initiatives at the American Society for Engineering Education. And I do many projects in those separate areas, pre-K-12 and DEI, but also do work at the intersection of those two areas. And so I also, in addition to that, do a lot of work on the higher ed side as well. So that's why we are joining here together to do this challenge, especially for 2- and 4-year institutions. And then we have another announcement at the end that I will share. So yep, just a little bit about me, background in math, engineering, and city planning. And I enjoy doing this type of work. So thank you again for having me.
Thank you, Geraldine. And, you know, I might call you in during this presentation because we're going to try to make this a little bit informal. And like Geraldine said, stay tuned because we might have good information towards the end, some free things we want to give away here. So I appreciate it. And the agenda for today is going to be like you see here on your screen. But like I said, we're going to try to make this more informal, more of a conversation. If you have any questions, you can put on the chat here. The three of us are going to try to monitor as much as we can the questions that are going on, because the whole intention here is to have this dialogue, okay? So first, I would like to explain why did we decide here at Autodesk to go in this contest with ASEE, and hopefully Geraldine can also say why ASEE decided to do this with Autodesk, right? So we realized very quickly, looking at ASEE vision, mission, and values, that they super align with what Autodesk is doing here and what we believe it should be done for education, and how we believe that everybody has to have access to education, how we need to be partners, industry and education in this workforce development, so much that a large majority of Autodesk products are free for students, educators, and educational institutions across the world. So it was a no-brainer to partner with ASEE to do this contest. But then when we first started conversation with ASEE, Geraldine here told me, Fab, perfect, this year is the year of racial impact, and we really want to do something that can instigate educators to think about social change. So Geraldine, feel free to jump in and say anything here, because that's your area of expertise. but based on our conversations is how can we actually facilitate a change using a contest where we ask educators to think more about that. And, you know, as we all know, it's super hard. It's not a one project is going to change. It's keeping the dialogue open that is going to make a change. And we know there is not, we wish there was a project or a design that would flip the conversation and make people think about these things. And you know that's not possible, but you want to be, like you see on the slide here, a little part of this change. You know, we cannot do this alone. So Geraldine, anything you want to add here?
Have you summed that up really nicely? We really just want having our participants to think about issues and challenges within their community and around their institution, and having their students think about how can they solve that problem. So we just want people to just reach out to the outermost edges of their imagination and come up with some solutions to some of the pressing issues that are facing our world today in the community. So we just want you to just be as creative as possible, no limits.
And, you know, myself as a former educator, I can only imagine all of you thinking, great, but how can I make a change with design or with a class or with a lesson plan or with a project? And I love this image. You probably saw this before on the internet. And is this explanation of the difference between equality and equity. But imagine you are the teacher creating a lesson plan, asking students to design that box. And that's how you can make that change, right? So I'm not going to read slides. Everybody on this attending this know how to read and write. And there's nothing more boring as a former educator, right? You all know that, than a teacher reading the PowerPoint, so I guess can read this. But I think this image is so powerful, right? So equality is what we see a lot today, is trying to give the same opportunity to everybody, but equity is you really have to make sure the opportunity reaches the people who need it the most, and maybe that opportunity is a little bit different. And that's the type of things we want you to think when you create this lesson plan to submit to this competition. So let's give a quick overview of the contest, you know, go through deadlines and all of these things. So we launched this in January. The final submission is due in May. So we have 2 months to go. So I hope everybody is like thinking about that. We didn't want this to take a long part of your time. You know, educators are busy. You know, educators have a lot to do. We know May is the end of the semester. Fab, are you crazy? But we understood when we decided to do this that lesson plans is something educators do day in and day out. You guys know how to do this. Chances are you might have a lesson plan you already used for something else that you can adapt to this contest. We have done tons of contests for students. And this time we want to switch this and say, hold on, let's celebrate our educators. Let's give prizes to our educators. And how can we do this without taxing too much of their time? So that's how this came to be a contest where you submit a lesson plan. You don't need to submit a project. You don't need to submit student work. And we're going to talk more about this. But keep in mind these deadlines. We're going to announce the winner during ASEE National Conference in June. Hopefully the winner can be there. And the prizes are cash. Who does not like cash? And you see here on the screen. So last time we did a Q&A session with educators, we took note of the questions they were asked the most. So we put what this contest is and what is not. So it is open to post-secondary only. So unfortunately, sorry, high school teachers, not for you yet. You know, please check. We have a competition website at Autodesk. You can check that to see what you can join. But this one, we decided to do just for post-secondary. Like I said, the entry is a lesson plan, and it is a lesson plan for social change. So what is going to be on your lesson plan that instigates your students to think about social change? And of course, you got to use Autodesk product, and specifically we're asking you to specify Fusion 360 in your lesson plan. It doesn't mean you need to be expert in Fusion 360. It doesn't mean that you need to know everything about the software. And actually, Josh is going to talk about the product in a little bit, and how he incorporated Fusion into his classes and into his lesson plans. And if you were still confused and thinking, I have no idea what I'm going to do other than those 3 boxes you show me. So here's some examples of projects or products that we work together. Even Autodesk has a residency program and people apply for the residency, or products that we publish on our blog called Redshift. If you want to check Redshift, you should. Redshift.com has some cool articles that change every week. So it's just examples. By the way, full disclaimer, we are not endorsing any particular product, right? I have to do the legalese, but it's just to get your mind and your juices going about ideas of what can this lesson plan, what can I ask my students to design? If it is a design project, it could be something else. But since we are asking you to use a CAD/CAM software, chances are you're going to have a design component to your lesson plan. So this example is BioLite. It's basically a wood camp stove. You can buy this right now if you want. But it also, when you're burning wood, it generates electricity. So if you live in a remote area, or if you are in a rural community and don't have access to electricity, you could charge electrical devices by just burning wood that you would be doing anyways. Another product that super cool is Socket. I did some research for this webinar and I found out that Socket is no longer for sale, but the lady who founded the company has now moved on and created this Uncharted Power, and is a Black-owned business, and she is a former Harvard student. So super excited for Socket. So Socket was a soccer ball that kids could play all day and charge a battery that then can be used to light up their house at night. So the group of students who designed this saw that in a lot of communities that didn't have access to electricity, but kids were playing soccer all day, and that could be a way to charge, even if it's only one light bulb for their families at night. Another product that we saw and we're super excited about and we published on our blog was this heater, HVAC unit heater called Gradient. And the idea here is if you don't have access to make a big remodeling of your house to put a central system or whatever, that would be a more affordable option for you to heat and cool your house. The other one is a picture of, this is a drone, but the company is called H2Go, which is using hydrogen as fuel for anything. And on this example for drones, and the drones can run longer and reach more remote areas that need resources. And not only that, the output of hydrogen here is just water. So you also have the climate change component into this. And that's another project Autodesk is working with Hyundai to create a vehicle that can go anywhere. There are tons of pictures on our website you can check where this vehicle is going through rocks and inside caves for rescue, but even urban areas, just to allow people who cannot move easily to have access to be more mobile in their lives. So this is just some ideas, and it's one lesson plan of your life. So it's not a whole course, and we understand that students are not going to be designing a whole car, but a lesson plan is an intention, correct? So we hope that this gives you some cool ideas of things you can do. And I know Josh comes next, and he can tell you a little bit more how he used that in his class. So
Thanks.
Should I stop sharing now, Josh, so you can share your screen?
I can take over.
Okay, cool.
Let me do this. Okay, thanks Fab for those super cool ideas. And to kind of get your creative juices flowing, I thought I would show some of the workspaces in Fusion. Fusion is a great CAD package. I've used it for quite a while. I've used a number of CAD packages over my life, and Fusion is my favorite, partially because it's got so many different options. So the basic workspace in Fusion is called the design workspace, and these are accessed up here at the top left. The design workspace is where you make your components. So if you're familiar with any kind of CAD package, you've got sketches that live in here. So I've got a profile sketch for the plate, as well as a sketch that locates the holes, and then features to create those holes. You can do a lot with the design, fillets, sweeps, anything that you would see in other CAD packages. And so that's the basic idea, but Fusion opens up lots more capabilities with the other spaces. So I'll just kind of go in order that they are here. The next one is generative design. And I have to figure out, I think it's this model. Nope. So this is a generative study, and the way generative design works inside of Fusion 360 allows you to take a shape, in this case, I've just got the letters here for Ivy Tech, and then create something with the geometry. Now, this isn't shaped optimization. This is instead taking the forces and manufacturing methods into consideration. So we're talking about social change, and one of the social aspects might be the amount of material that a certain product uses. And so by using a generative study, then you can say, okay, here is where, in this case, we have what's known as preserved geometry. That's where I want to keep material because either it's an important feature for the design or maybe another component is interfacing there. And then we have keep out spaces as well, obstacle geometry, where we say we don't want anything there. In this case, a pencil might be going through that area. And then you'd run the study. I'm not going to do that now because it's going to take a little bit of time. It's already been done. But this brings me to one of the next nice things about Fusion is that when we do heavy work like this, such as creating results from a generative study, that's all done in the cloud. And so I don't have to have the world's most powerful computer to be able to run these generative results. I can instead just say, okay, start that study, and it will take that study, put it in the cloud, not even loading my computer. Once the results are here, I can view them based on their properties. I can view them on a scatter plot to see, okay, maybe I want to look at the factor of safety versus the mass and see which one is both strongest and lightest, and then compare that. Once I have a study picked out, I can then export it and bring it into an, you'll notice now I'm back in the design workspace. This is a different file essentially, and then I can tweak that design to my liking. So this is kind of a really free-form thing, and this was just supposed to be kind of a handout promotional artifact. I see there's a question in the chat here. Can you collaborate on an entry? Fab, Geraldine, do you want to answer that?
Yes, I can jump in. No, Mandy, I'm sorry. For now, we were doing only for individual entries, but that's a great idea for us to think in the future. And the other thing I want to say, Josh, thank you. And I know you have more to show, but I just want to make sure that the faculty attending this training, they make the connection. So for example, why is Josh showing this cool stuff? Well, generative design, for example, you can use it to reduce the amount of material used on a project. So let's suppose the issue around your community is trash or it is recycling. Maybe your project says you use generative design to create a product that uses less material. So that's the kind of idea that we are thinking for the lesson plans. Right, Josh?
Correct. We could also take that and look at mass. If maybe there's, I have some friends who live overseas, in Congo specifically, and I know that they have to do a lot of travel from city to city. So perhaps you're looking at some kind of component or getting a way to move, food from one place to another while reducing the mass. And so you could use something as like generative design. One of the nice things about the generative design workspace is it allows you to specify your manufacturing methods. And so when you look here, you'll see that I've turned on cost estimation, and so it's going to give me a rough estimate of the costs. But I've also got options here for how this product is going to be manufactured. In this case, I just wanted a bunch of different options, so I put in unrestricted, so there's no constraints on how it's made. But I could say, you know what, because of cost or whatever, we're going to reduce this to 2-axis cutting. And you'll notice when I hover over here, we get tooltips, and it kind of gives me an idea of, yeah, this is what to expect for the output, the kinds of things that can be done. So that's one nice thing about generative is you can specify that. That brings me to the next workspace, which is the render workspace. And this particular model I made as a demonstration for a 3D printer we were trying out. And I wanted to just test the capabilities of it and try some different textures because it was a full color design as well. Now this is a really organic shape, and you can see here I started actually with a form, so let me go back and edit that to show some of the capabilities. Fusion doesn't just allow for your standard square extrudes and fillets, it also allows for different kinds of geometry creation like this. So when you have a form like this, you can select different entities and modify them first, such that I could pull this point out. And let me grab something else. I'm sorry, I grabbed a vertex instead. And I can adjust the size or the angle of that particular face to give it the shape that I want specifically. So here I can say, okay, maybe I want that to bump out a little bit more. That gives me a lot of free form capability to be able to make an object such as this. And then I can, once I'm finished, this is still in the design workspace, you can see. Now let's say I want to actually communicate this design to a stakeholder. Maybe, there's somebody who doesn't have technology access. They don't have a computer that can run CAD, but I still want to share some version of the design. Well, that would actually take us into the render workspace, where we can set up lights, cameras, and give kind of a realistic view, including shadows of what that would look like. Once again, rendering is kind of more of a high horsepower type of thing in terms of computing. So this is something that's also done in the cloud. And you can see here's a render that I completed of this object, and then I also 3D printed it. Now that brings me to the next workspace, which is our animation workspace. And I have an object here. So sometimes once you've created an assembly, you do want to be able to show how it's assembled. And of course, we can do that best with pictures. One thing I like to communicate with my students about assembly instructions in particular is to think about Lego. Lego does a really good job of communicating ideas without using any words. It's just pictures showing how things go together. And so you could set something up like that in this animation workspace where we've got the different components all going together, and it shows how they're all assembled. Once again, I didn't have to create a new file for this. After I created the actual objects, in this case, the whole assembly, I can then move right into the animation workspace and create that. Once again, this is helpful for kind of communicating the design intent. That brings me to the simulation workspace. And simulation allows us to take a component and kind of check out its stresses. So in this case, I intentionally overload this. It will surely fail. But it gives us an idea of how the object is going to bend and how it's going to break. This is, once again, part of the same workspace. So the geometry, I don't have to recreate any geometry to put it into my simulation workspace, although I could simplify it if I needed to. It'll allow me to view those results and then communicate those clearly to others afterwards. Now, 3D printing is good and it's fun, but sometimes you need to machine something. And so the next workspace is our manufacturer workspace. And in this manufacturer workspace, we have the capability to not just machine the part, but we also have the capability to preview some of the settings. So there's options up here for setting up your tooling and machines, and kind of going through all that is outside of the focus of this particular webinar. It would take a little bit of time, but we could take this and simulate that toolpath after we've set it up to make sure that, for example, there aren't going to be any collisions between the tool and the objects around. So a lot of times a milling like this will be a way of reducing cost of a part, especially if we can get that milling operation down to a simple one. And so that would be helpful. When we look at some of the ideas like the BioLite, I thought that was a super cool idea. And being able to set up a tool path for that outer shell, that stainless steel shell with all the hole punches in it, would be extremely useful and allow us to drive the cost down, so then we could market it and get it to the people who actually need it. The final workspace that's listed off to the side here is drawing workspace. And I'm not going to go into this a lot, but this is your basic dimension drawings. You can create the views, and these are all linked to the Fusion model. So if I make changes in the Fusion model, it will propagate through and update everything, including the drawing automatically. Dimensions will also be updated. So that's very handy. One of the workspaces that's newer to me in particular is the electronics workspace. And I'm not sure I could tell you exactly why it's located in a different spot yet, but up here under the file menu, you've got options for new electronics design or new electronics library. And so that brings us into a different workspace where we can lay out simulations, schematics, and circuit boards. This is also linked to a 3D model. So if I've mapped these components, these resistors and capacitors would generate a 3D model so that we could then use those in our design. So all that's located inside of Fusion. And there's another option that allows us to go into sharing the design. So if we had this design right here, for example, that's not the one I'm in. Let me go back just a quick second.
And then as you go back, Josh, if
yes.
you don't mind me jumping in, and the reason why we asked Josh to show all this is, like I said, not only he created his lesson plans, he was an Autodesk conference speaker exactly about how he used that in his classroom. But because by showing all these different workspaces, you might be thinking, hold on, but I'm an electrical engineering teacher. I don't know, so there is this, you can submit whatever is your area of expertise for your lesson plan. You don't need to be doing, let's suppose you're a community college machining instructor and you want to submit some lesson plan you created for machining. You can do that and still be within the realms of what Fusion can do. The hard part is not going to be the software. The hard part is going to be, how do you attach that to a social change issue? And that's what we want you to think about.
Right. So the last thing I kind of wanted to show here was the public link. So if I have a design and I want to share it with somebody, I can right click here and click share public link, and that will allow me to allow this object to be downloaded, for example, or just allow it to be shared with somebody. So I can copy this link, they can then open it inside of a web browser and view this 3D model without even having Fusion. It'll work on a mobile device as well as like a laptop or desktop computer, more of a traditional computer. So it allows perhaps stakeholders to give feedback into the design. All right, and then Fab, I think we're turning it back over to you.
Thank you so much, Josh. And for the last part that you showed, what I like too is the collaboration, right? So let's suppose your lesson plan is a team group work. We all know how students love group work, but at least inside of Fusion, you can see the students invite you to a project and you can see every time everybody saves something, you can add comments, they can add comments to each other. So this way, you kind of don't eliminate completely, but you minimize the problem of having somebody on the team that doesn't do anything, because then you can ask on your lesson plan, create this whatever project it is in a group, but make sure you add comments on your versions of the design, right? So like what Josh is doing here. And you as the instructor can even see that, like he said, on your mobile device. You can download the app and you can send comments back about the design to the students. They can talk to each other that way, especially in the day and age of hybrid delivery. That is a big help, and you can incorporate that into your lesson plan if you want. So that helps students, for example, which I had many of them who could not come to campus to do group work because they had a job all day. They were my students at night. They cannot come to campus and meet with a team, right? So that solves that problem as well. So I'm gonna share again, Josh. Can I share my screen?
Go ahead.
And let me see here. I'm viewing your screen, so let me go and share this one. Okay. Let me know if you see my big screen, not my presentation mode. You see my big screen? You see yourselves for a second?
It's correct.
Thumbs up. Cool. So, so now let's talk about the lesson plans, right, themselves. Of course, like we said, you're educators. We all know, you know what a lesson plan is, but I know they can be all different. And we want to just do a quick reminder of the things our judges will be looking for. So, like minimum things we would like to include is, of course, the objectives. And again, I'm going to tell you, this is not a course plan. It's one day of the life of your course lesson. So after today, after this one lesson, the students will be able to X. We always ask you to put verbs that you can measure. So if you say students will learn this, it's kind of hard to measure did they actually learn. But if you say students will be able to design X or to describe Y, that helps. I know Josh has something to say about that as well from a point of view of a chair, and he advises his faculty. Please describe what the lesson is about. Like I said, not everybody on this call or participate on the contest have to know Fusion. They don't even need to know CAD. So your lesson plan could be a group project for the students to do a final element analysis of existing things in order to improve them for the community, right? How long is the lesson? How long does it take to complete that? So your lesson is a lecture, is a project, is that an hour, 2 hours, is an hour in class, 3 hours outside the class? And then I used to be a chair, by the way, and I used to tell my faculty, to always have their lesson plans ready in case they could not come teach the class today. Could I grab your lesson plan and teach your class for you? Even if I didn't know what was going on in the class. To me, that's an example of a good lesson plan, is a roadmap for me, even if I'm not an expert, even if I don't know what's going on, I can at least be a halfway decent sub that day. So does that sound right, Josh?
Yeah, and there's one thing I would probably add too, although it's not necessarily applicable for every lesson plan. One thing is to think about if there are any materials. So, if you're going to have your students make some prototypes or make some sketches, you want to make sure you list those on the lesson plan. It may not be applicable in every situation, but it's a good thing to remember.
And I know, Geraldine, you're an educator as well, so feel free to jump in if I miss anything about the lesson plans here. And also, you all participating, if you have something to say on the chat, you are, experts, and say, Fab, you forgot this, that's fine. We can mention that, okay? That would be awesome. So again, to recap what we said here, the lesson plan is not for the whole course. I know that would be way too much work. Can you imagine if you're asking you to send us a whole plan for a semester? You would be insane. We don't want you to take that much time of your life to participate on this contest. It has to have the description of what the assignment is, even if it's not a design assignment. If you don't know Fusion, is fine. We hope after this you go and play with it a little bit. Like I said, it's free, you can download it, but just at least name the features of these environments that Josh just showed it to you. On the contest page, there are resources for you to explore more. We have a YouTube channel, and you can even request a lecture for your class. So you can enter your name there and request a lecture for you and your fellow faculty members. And we do not need bibliography, it's not an academic paper. And please do not include the student work. We don't need to see those, and we are very concerned about privacy as well. And sometimes when you submit student work, a name might show up or something, and without permission, we shouldn't be able to see that, as you know. So we don't need to see the result of your lesson plan. It's not like, this was the lesson I gave, this is what the students produced. We do not need that. Make sense? Geraldine, anything from you? You good?
Nope, sounds good.
Josh, sorry, go ahead.
No, I said, sounds good, Fab. You pretty much had that. One thing I just wanted to add was just to make clear what level your lesson plan is for, freshman, undergraduate, graduate, just be clear on that so we know where you're coming from, what level.
Yes.
Yes.
Excellent point. This is a great point. If you can put like, what is your program, right? This is a mechanical engineering program. This is a associate degree in welding. I don't care. We really want the community colleges to participate on this as well. And the level of the class is not going to be a factor for the judge, right? It's like, we don't want to give an advantage to somebody teaching a senior capstone opposite to somebody teaching a GD&T basic class of drafting, for example. It's about the creativity, really. Go ahead, Josh.
Yeah, creativity is key for sure, and that's really one thing that helps engage students. So I thought I would talk a little bit about some of the planning process for objectives here, and for lesson plans, because I think I kind of determine objectives at the start. So when I'm sitting down to make a new lesson, I'll think, okay, why am I making this new lesson? It's typically because I want the students to learn something. In some cases, it could be that objectives are already given. So I've definitely got objectives that are given to me by the college. And in other cases, it could be, I've just noticed the whole class needs to learn X. They're all deficient in, this concept in dimensioning or something like that. And so I could set that objective up at the beginning. It's also helpful to think about what you want the student to deliver. So I teach mostly engineering courses. And so it's most helpful for me to think, okay, when they're finished, what are they going to turn into me? And that kind of helps drive the rest of the planning process. So examples would be, what do you want them to turn in? Do you want them to turn in an actual CAD file? Do you want them to turn in an executive summary of some kind of research? Should they turn in dimension drawings? That's one thing I have to talk with the students about, is like, what's the difference between a model versus a drawing, and where are they appropriate? A functional prototype, a toolpath. or some combination of these. I will say a lot of my lessons will include multiple combinations. I think it's always helpful to share those objectives with students during the introduction of a lesson. So if you look over here on the right side, this is just a bunch of screenshots that I used in an Autodesk University presentation for some different lessons. So we could see a toolpath being generated there, an actual 3D printed model. And then down below, this particular course was actually something that happened during the pandemic. So we started this course and then everybody had to go home and we had to be virtual. So one of the components of this course, one of the objectives was Kaizen, trying to figure out, okay, how do we organize things in a way that helps manufacturing and improve efficiency? And, I was thinking about, I had a plan for what I wanted them to do in class, but that totally changed. So I actually modified that for that particular lesson and still delivered the content, but I said, okay, now go home and arrange a junk drawer in your house and lay it out, using these principles about what objects are used most frequently, which objects should even be in the drawer and how to organize those. And so that was, in that case, the deliverable was the students' work, but what they actually submitted to me was a picture because, I wasn't there since we were virtual at that point. Next. So the next thing I want to talk a little bit about is the grading process, because I think any good lesson plan is also going to come with some kind of criteria of how you're going to determine, how you're going to evaluate basically. And this is usually a two-way evaluation, both an evaluation of the student's work and evaluation of how well your teaching went. I've definitely had times where, I assess the students and it's like, okay, clearly I missed something because they didn't learn what I thought I told them. And if it's the whole class, it's probably me. If it's half the class, it's probably still me. So I would say, start off by determining those grading criteria. It's typically really simple to determine good work from poor work. I have very little problems doing that. It's obvious even to somebody who hasn't taught the course. But the real rub comes in, how do you separate the good from the grade? And there's a lot of considerations, sometimes, we may have two students that come into the course with different levels of experience. Maybe somebody's already got CAD background and someone else doesn't, but how do I determine that and how do I grade it equitably? And so we start to look at things like effort, but effort is hard to grade. It's hard to figure out how much did a student work on this. We look at documentation, that's a little bit easier. I've got a screenshot over here of a particular file. Oh, nope, sorry, Fab, go back one. And this is a flyout from the data panel on the left side of Fusion. And so what you can see here is all the different revisions, all the different version histories. This allows me, and this particular project was just an individual student, but there were other projects in the course that had multiple students working on them. And I guess this is a good point to mention the way Fusion kind of handles things. When you design a project in Fusion, you can either have the students create the project themselves and invite you to it, or you as the instructor could create the project and invite the students to it. And I kind of depend on how much group work I'm going to have. So if the course is a mostly individual course, or it's got, maybe a final group project, what I'll typically do is have the students create their own projects and then invite me to those so I can see them. If it's a project where it's going to be really group work heavy, I would create the project and invite the students to it. Either way, it's going to work just fine. But once you have access to that, you can actually look through the version history here and see, okay, when was the file opened? When was it saved? Who worked on it? And that allows me to really kind of put, a tangible marker on that effort concept. I also like to use a rubric, and you can go now to the next slide, Fab, here. And I've got a screenshot of a rubric, which I realize is very text heavy, but there's a couple of things I want to point out about the rubric. So first of all, notice I don't have like 20 categories. I typically like to keep things simple because that's just how my brain works best. So we look at things like research, like usability, like critical thinking. Some of that stuff, the critical thinking is was the student actually working on it? Was there considerable effort put into the project? Sketches were required with this project, and they're not necessarily captured directly in Fusion, although you can upload sketch files into Fusion and you could grade that way. But this allows me to break those concepts down into parts that I can then assign points to. You look down at the CAD models, you can see there's an option there for the effort, the level of difficulty. And then one thing I personally like to do is you'll notice all my ratings, they are even numbers. So in neatness, there's 4 categories. In usability, well, that was just like, did it work or not? That's 2 categories. And I do that intentionally because what I've noticed in my own grading and even in some others is that, you get a great project, like I said, it's really easy to grade that. You get a poor project, it's easy to grade that. You get one in the middle, it's like, well, it's average, and it's average for everything. And then so you get a few that are really good, a few that aren't quite hitting the mark, and then everything else is right down the middle, and everybody else earns like a 75. And that that doesn't typically match with what the student's effort or work typically was. So what I have always done with my rubrics, I should say always, what I try to do now with my rubrics is separate them into even categories so that I'm forced to say, yes, this is above average, or no, this is below average. In this case, the categories are actually, exceeds expectations, meets expectations, needs improvement, or no marks. So those are the 4 categories that I kind of stick with. There are some things, of course, it's just a yes or no. Fab, Geraldine, other comments or thoughts about rubric design that I'm missing here?
I have to say, this is so good because I'll be honest, I did not create rubrics for every lesson. I did for the whole class, but I think the moment you do it per lesson, it forces you to think about the deliverables for the day, right? As an educator. So I love it. I love the 4 instead of 3 because I can totally see myself in the past doing that. Everybody gets a C, right? And yeah, no, I get it. I love it. It's super. And then we have our own rubric here for the competition as well. And we fail based on your discussion. Just kidding.
It has 3 categories.
It has 3 categories. You're not passing your class, Josh.
No, this is a very good way of doing it. I might start incorporating it myself. So thank you for sharing that.
You're most welcome.
You're gonna get emails from people like, can you share your rubrics with us?
And Fab's talking up here. I do not have a rubric for everything, but I do have rubrics for kind of those big rock projects. So the next thing is kind of so we talked about the teaching process in terms of developing the objectives, then looking at the rubric. And then the last thing I wanted to mention here about this was the teaching topics, because a lot of times I come up with this idea for a project or a concept, and the students might not know exactly what they need to know. There may be gaps in their learning. And that could vary based on the section of the class. Maybe one semester I've got a bunch of students that have all got industry experience, and so they're kind of ahead, and I can move on to a different topic. They don't necessarily need me to talk about, assembly because they've done it. But I might get another section of students which are all, kind of younger students who haven't had jobs, and then we actually need to go through some of that. So in this case, I would pause and think about what do students need to know, and you may actually even have bullets on your lesson plan about, okay, here are the key concepts that need to be delivered to students. And I like to do kind of mini lectures. I won't necessarily stand and lecture for an hour, but I might say, okay, let's just talk about the basics behind toolpath generation. And so that's what I've got a screenshot here of some of the basics of that, and would talk with students about that and give kind of a mini lesson so they've got that information right there. That way it's kind of bundled into the lesson plan. Not every PowerPoint needs to be in the lesson plan. Not every single note sheet needs to be there, but it at least gives an idea of the concepts that the students would need to know to be successful in that lesson.
Thank you, Josh. And talking about rubrics, these are the judging rubrics, is available on the contest website as well, but we wanted to put that here and allow everybody attending the webinar to ask any questions they have about it. Because I don't know about you, but a lot of times when I did contests for myself or my students, I would go and see what the criteria is first and try to make sense of it. And we created this rubrics so you know how people are going to be judged, and also to help our judges. So when they are judging all the lesson plans, they can look at this. And the idea is for every judge to judge everybody, and then we do a simple addition of the scores. So it's not on each judge only sees one project, everybody sees everything. Everybody's going to see all the lesson plans, and then we do a simple addition. And the main criteria, as you can see here, are the innovation of your lesson plans, right? How creative it is, the clarity, if it's easy to follow. Of course, a big point here, what is the social issue you are tackling, right? And how do you go about tackling it using in engineering, a technical issue that you teach or whatever that may be. So if you have any questions about that, please feel free to put on the chat. And then if you cannot think of any questions right now, here are our contact information that you can ask after the presentation. We only have about 5 minutes here. And I know that we said we're going to keep the good news to the end, and Geraldine is going to talk more about that. The intention is we really want more 2-year schools, community colleges to join ASEE. So Autodesk made a donation in order to help ASEE give free membership for community colleges. Right, Geraldine, you want to talk about that a little bit?
Yes. So Fab, you pretty much covered what I was going to say. So Autodesk generously gave ASEE funds to be able to support community colleges in getting ASEE membership. So just to give a little bit more information about that, the institutions, or say departments that qualify for that would be related to a STEM field. So mostly engineering, tech departments, American Society of Engineering Education, as you can see, it's for engineering educators. So the sponsor, the membership would be for departments that fall in that category. So tech, engineering, computer science. And so if your institution is not already a member, you can have your dean or chair contact me to be able to access those funds to become, to receive complimentary membership to ASEE for a year. So that's great news. I hope many of you will take advantage of that because that's an awesome deal. And some of the benefits with that is you get access to our award-winning Prism magazine. You will receive discount registration to our conferences, and you will have access to participate. We have over 50 different divisions within various disciplines. So we've got electrical engineering, industrial engineering. To your college division, we have undergraduate experience. We have lots of different divisions. And our website is there so that you can take a look at the different divisions that you can be a part of and communicate with other of your colleagues that are also across the country, across the United States, even outside of the country, to do collaborations. A lot of our members get together and work on grants together, receive funding together. So there's a lot of opportunities once you become, your institution becomes a member. And if you decide to become a member as well, there's also great opportunities there. So if you're interested, please feel free to reach out to me and I can let you know how your institution can become a member. And this is specifically for 2-year colleges for this particular funding opportunity.
That is great, Geraldine, and I can assure that the divisions are amazing. It's a great networking opportunity as well. Like I said, I volunteer for 2 divisions. There are so many, it's hard to pick and choose the ones you want to join. So we are super happy here at Autodesk to be able to fund this opportunity for community colleges because the dialogue between 2-year schools and 4-year schools is essential for the success of both organizations. And we want to support ASEE in this effort to have more 2-year schools members. And then, so that's, I'm going to stop sharing here so we can see our faces and answer any chat questions with a little bit of time we have left. Anybody else has a question? You can tap on the chat.
And you're also free to ask any questions. If you don't think of any right now, you can reach out to us through email. Be happy to answer any questions. Again, the contest is open for another 2 months, just about, till May 13th. Yep. So don't wait till the last minute. I mean, you can, but so it's good to get it in early if you can. And yep, just feel free to reach out to any of us if you have questions.
You know, I had a question for an educator before, how long the lesson plan has to be, like how many pages? And there is no limit. There is not a short one or a long one, is whatever you feel is necessary, but the intention here is not, like I said, the intention is not to make your guys' life harder. It's not to be a very long process. I don't know, my lesson plans had 2 pages, so maybe 1 sometimes, right? It's like, this is the lesson today, this is the assignment we're gonna do, this is the tools you're gonna use, and Fusion will be one of the tools. This is the main objective, that would be your social change thing, right? And if you need more pages, by all means, right? Sometimes you have graphics, you have things you need to show, of course, there's no limit. And thank you, Luis. He might have left already, but good to see on the chat there, all the educators. So if we don't get any more questions, I am going to say a huge thank you to Josh, who volunteered his time to be here. I want to say a big thank you to our judges. I know one of my judges is here watching this. Corey, thank you. I saw you there. Appreciate it. So we have judges from academia, from Autodesk, is all the judges' bios are on our website. Josh, by volunteer today, can no longer enter the contest, and that we are sad, but thank you. We don't want to avoid conflict of interest, but thank you so much for being here. But Ivy Tech people can join. Thank you, Ivy Tech, for allowing you to volunteer for us. Thank you to Geraldine for jumping in this call and being our special guest and being such a good partner organizing this contest. Let's change the world one lesson plan at a time. Thank you all. We're going to put a recording on the websites, the contest website, probably ASEE website. Keep an eye for our next webinar. Thank you.
Thank you, everyone. Bye.